We are still in the Cartesian system. Now we'll want to find the trajectory equation. We talked about the displacement vector, so the object is moving. Then since it's moving, then we have a certain trajectory. We said that we have different forms of trajectory, such that the rectilinear trajectory, curvilinear trajectory, and circular trajectory. But we find the form of the trajectory, we found it using the observation. But what if now we don't have a figure? How can we know the nature of this trajectory by calculation? For example, if you have this object, this cat that's moving, so if we notice the trajectory, it's a curve, then it's a curvilinear trajectory. By observation, we found the answer. Now, as trajectory, it's a relation, if we notice, it's a relation between y and x independent of time. So a trajectory equation is an equation which is a relation between y and x independent of time. What if we don't have this figure, but we have only the position vector, means the cat is moving along this position vector with respect to time. And the question was, find the nature of trajectory of described by the cat. So how to find in this case the nature? So when we have only the position vector, that we will have many steps in order to find the trajectory. So the steps are: 1, we find x, we write x and y. This is what we call the parametric equation. Second, we find t in terms of x. Third, we substitute t in y. So by substitution, we will have a relation which is independent, a relation between y and x, which is independent of time. This relation, this equation, is called the trajectory equation. But now, how to know the nature of this equation? Is it a curve, is it a line, or is it a circle? So here we must notice the equation. If the equation was of the form y equal ax plus b, where the degree is only 1 or 0, then in this case it's a line, so it's a rectilinear trajectory. If the equation obtained was of the form x squared plus y squared minus 2ax minus 2by plus c equals to 0, then this is the equation of a circle. Then in this case the trajectory is circular. But notice that here the coefficient it's 1, and here also it's 1. So it's x squared plus y squared. Now, what if the equation was of the form y equal ax to the power n? Then in this case it will be a curve such that n is bigger than 1. For example, y equal 5x squared minus 3, y equal 2x to the power 3 plus 5x squared minus 1. So it's an equation where the degree of x is bigger than 1. So now, finding the trajectory equation, continuing the application 1, you have the position vector rt equal t plus 1i plus minus t squared plus 2tj. The question now, part 3a, write the parametric equations and then determine the trajectory equation of motion and indicate its nature. So parametric equations are x and y, as we said, such that in this part we have x equals to t plus 1 and y equal minus t squared plus 2t. Now, in order to find the trajectory equation, we said we have 3 steps. First step, find the parametric equation. So this is part A. Second step, we find t in terms of x. So using t equal x minus 1, means here we find t in terms of x. Then we substitute, third step, we substitute t in y. Then we'll have y equal minus t squared plus 2t. By substitution, t equal x minus 1, it will be minus x minus 1 square plus 2x minus 1, and by expanding we'll have this equation. Now, after finding the equation, we want to indicate the form of the trajectory, its nature. So in order to indicate its nature, we compare it to the equations. We notice that this equation is of the form y equal ax to the power n, where n is bigger than 1. Then this equation is the equation of a curve. This means the trajectory is curvilinear. Now, if the question was, represent the trajectory of m, so we knew now that the trajectory is curvilinear. So if we want to represent it, we must have a curve. But how to represent the trajectory if asked? So in order to represent the trajectory, we take many points. Example, Let, for example, we have y equal minus x squared plus 4x minus 3. This was the equation we found. So we choose some points. For example, for x equals to 0, we substitute, we find y, and etc. So we take many points and we join the points, then we obtain the curve. So we notice that this equation, which is independent of time, by representing it, it will be a curve. This means the trajectory is curvilinear. But is this the trajectory of the object in motion? Does the object in motion start from here, from this point? So how to know? So now we will take the time which is at t equals to 0. At t equals to 0, we had x equal 1 and y equals to 0 by substitution. This means the object, when it moves at t equals to 0, it starts from the point where x equal 1 and y equals to 0, which is here, this point. This means the trajectory of the object is only the part which is in green. This is the trajectory described by the object.